Alright, so this is going to be our next notes on in algebra. This is lesson 4.3. We've been talking about the first two lessons about slope-intercept form and point-slope form, and now we're going to tie some line ideas into that, and specifically parallel and perpendicular lines. And we want to first define each one of these and then see how we can use what we know about these types of lines to solve for unknowns. So you should already know a parallel line is just a line, or parallel lines are lines in the same plane that do not intersect. And so like if we were going to draw a picture, and the main thing you have to remember is they do not intersect. So if we were going to just draw, there's a piece of graph paper here, maybe add to it here. So we would say if this is our xy, we would say these two lines are parallel, right there, and then they could even be up and down like this. As long as there's something like y equals something and y equals something, they're parallel as long as they never cross. So those are examples of parallel lines. And we can use the fact that they're parallel, and we can use some things about point and slope to find the equation of those lines that we are going to learn about, these parallel and perpendicular lines. So let's look and see how we do that. Okay, and it's just knowing the fact that this line is parallel to a line we already know what the equation is. We can then use that. Since they're parallel, they have some conditions that are always true. And one of them is the fact that they have the same slope. And if we know the slope of the other line, we can then plug that into the line we don't know the slope and realize that that's what it is as well. Okay, so our example here says, so if we have a line that runs through point -3, 5, and that's the x is -3 and the y is 5, and it's parallel to another line that's y equals 2x minus 4, how can we then write this line with just those 2 points into a line that is in points or slope-intercept form? Okay, so the first thing we're going to do here is we're going to write the line in point-slope form. Okay, and if you remember, the point-slope form is y minus y1 equals the slope m times x minus x1. And that's our general form. And then we can take these points, -3 and 5, and we can plug them in where they go. So it's going to be y minus 5 equals m. We need the slope, right? We know the slope of this line up here is the same, and we know it's the one right next to the x, which is 2. So then we go 2x, and then x1 is -3. So x minus a negative is going to be +3. And then we're then going to use the distributive property, y minus 5 equals 2x plus 6. And then we're going to add 5 to both sides. I'm going to have to write it over here. So then we'll get y equals 2x plus 11. And then we have, we've collected our like terms, like it said down here. So we have point-slope form. We then collected the like terms like we did here. We added 5 to both sides. We also did the distributive property here, right? We had this 2, ran that through. So we got this answer, y equals 2x plus 11. And that's in slope-intercept form, and that works good. And that's kind of how you do that. So you can use these points, use the slope of this, use the point-slope form, which is right here, plug your points in, y1 and x1, use the slope from the other line, then do the algebra, and then you should, in the end, be in point-slope form. So let's keep going on that. So that's kind of how you do that. So that's a parallel line and how it can be useful with knowing points and slope and such. But also we have something called a perpendicular line. You might know what this means, you probably do. And these are lines, if you have 2 or more lines, that intersect at right angles, or 90 degrees. So if you were going to write those lines, they would look something like this. probably see them. And most times, if they're a right angle, they're going to have like a little square there that tells you that's 90 degrees. So these two lines would be perpendicular. We could even have another line here, and these two lines would be perpendicular. We could have another line over here, and these would be perpendicular. As long as where they meet, it's 90 degrees. And it's denoted by using that box. It's kind of a perpendicular. And we can use the idea of perpendicular and recognize if lines are perpendicular like that at 90 degrees, that the slope of those lines that they're perpendicular will be opposite and reciprocal. So opposite, so if it's a positive, it's going to be a negative. If it's a negative, it's going to be a positive. But reciprocal means it flips. Okay, so let's kind of show you what I mean here. So let's say we have these two lines. Maybe this is, I'm not going to put the slope actually, but we have line 1 has a slope of 4. And then line number 2 runs perpendicular to that, so we then know that the slope will be opposite that and reciprocal. Sometimes it's easier to do the reciprocal part first, so the reciprocal of 4 is 1/4. So then we know we have the reciprocal, and then it's the opposite, negative 1/4. So if we had two lines, and we knew that one of the slope was 4, and the other one was perpendicular, we would know the new slope of the other line, or the slope of the other line's perpendicular, would be negative 1/4. Okay? And you can kind of use that to help you figure out the equation for a line. And if you want to know if lines are perpendicular or not, you can compare the slope if you have points and see if they are. And let me see if I can show you an example of that. So here's an example of this. So we have these two lines here, and this was kind of a problem where it says this quadrilateral, this coordinate system is actually a garden, and you have two paths that run through it. This line A to C is one path, and then line D to B is another path, or B to D, doesn't matter. And you want to figure out, are these paths perpendicular to each other? So all you have to do is to determine the slope. So we look at AC. So we have line AC. See if I can get a pen that works here. It's this one, I guess. So we have line AC. And we know the points for that are -2 and 1, and 5 and 7. And then we have line DB or BD, it doesn't matter. We'll just go DB. And D is -3, 4, and then B is 3, 3. Okay, and then we just do the slope formula, which is M, write it up here, equals the change in Y, right? Y2 minus Y1 over X2 minus X1. We solve that and we'll have the slope. We'll do each one by itself. So here we're going to say this is the number 2 one, this is the number 1, so this will be X1, or Y1, this will be X2, Y2. So we'll plug it in, M equals 7 minus 1 for the Y's, and then the bottom part, X2 is 5 minus -2. And then we're going to figure that out. So 7 minus 1 is 6, and then this is actually going to be added. It's going to be 5 minus a -2. We change the sign and add. So it's 6 over 7. That's the slope for that one. We then do the slope for this one down here. We'll say again this is 2 and 1. It doesn't matter really, but we'll just stay with the same formula we've been using, with the same method. So here we have -3 minus 4. And then we have, that's your Y's. And then we have 3 minus -3. So here, -3 minus 4, we're just going to add them, change the sign and add. It's going to be -7. And this one is going to be adding, because it's 3 minus a 3, so we're going to change the sign and add. It's -7 over 6. And then we remember it has to be reciprocal, which would be, the first one is 6 over 7, so it should flip 7 over 6. And then it should also be the opposite, a negative, so these are perpendicular. So that's an example of that. How you can compare lines, just use slope and see if the slopes are, if it's looking for perpendicular, are they opposite and reciprocal. So that's that. Okay, so this one here is a little bit different. We've done the perpendicular lines comparing slope, and we've converted using the point-slope form into the slope-intercept form and seeing if the slopes are the same. And now we're going to use points and the slope to find the slope of another line. Okay, so here we have a line that has points -4 and 6. So that line runs through these points. And then it has a line that's perpendicular to it that is its standard form is 2x plus 3y equals 12. Okay? So the first thing we want to do here, and it doesn't really matter, you could do the second part I'm going to do here first, it doesn't matter. But I usually start off by finding the slope of the line that's perpendicular. So I start off, I have the standard form, and I want to convert it into slope-intercept form. So I'm going to have to get it so it says y equals something. So the first thing I'm going to do is I'm going to minus 2x on both sides. That's going to give me 3y. These cancel, right? And then it's going to be equals 12 minus 2x. Then I'm going to divide by 3 on both sides. This is going to cancel. It's going to give me y. It's going to be 12 divided by 3 is 4. Okay? And then it's going to be minus 2/3 x. Okay? And then I just need to rearrange this a little bit. I want to always just remember for myself is to have x first. So this is the same as saying y equals -2/3 x plus 4. Okay. So this tells us right here, there's your slope. Okay. So now we've taken that line that was in standard form up here, 2x plus 3y equals 12. We've turned it into slope-intercept. And now we just take the points that we have, -4 and 6, and find out the slope-intercept form for that. So again, we're going to use the point-slope form, which is y minus y1 equals m times x minus x1. So we're going to start there. Okay, and then you can see in this equation we have a y and we have an x, these things right here, but the only thing we're missing is the slope, and we're saying if we have this one line, we want to write a line that's perpendicular to it. And what line would that be? We're then going to use this slope that we found out, and again it's going to make it for the new line that's perpendicular, we're going to want to find the reciprocal, which is 3 halves, and then it's a negative, so we're going to want to do the opposite. So for this line, our slope's going to be 3/2. So we're going to plug all that in. Y equals y1, which is right here, y minus 6, I'm sorry, not equal. Then that equals 3 halves times x, then minus x1 is minus a 4. And then I'm going to do some math here. Y minus 6 equals 3 halves x, and then I'm going to get rid of this. Then I'm going to do the I'm actually going to change the sign. Then I don't have to worry about the negative. So I'm going to take 3 times 4 is 12, 12/2. So it's going to be a positive 12/2, and then that's going to be 6, right? That'll be 6. So then I have my form. Then I have y minus 6 equals 3 halves x plus 6. And then I just need to move my 6 over, add 6 to both sides, and I get y equals 3 halves x plus 12. And then I could plug that line in. I know my y-intercept. I know the slope. I put the 1 point in, move down the slope. And if I have this line already in, I can then put both of these on a graph, and they would be perpendicular lines. So that's kind of your notes for this. I hope they all make sense. Let me know if you have any questions. You can add notes to this in YouTube if that's how you watch them. And see you in class.